Welcome to Tech Teach.
Here we will be going to consider the universal shift register. So before going to see the universal shift register, we will be looking like what is the shift registers first. The shift registers are made up of different flip-flops, or shift registers are considered to be the group of flip-flops. A different group of flip-flops are going to constitute the shift registers, and we have already seen different types of shift registers like serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. So these are the four different categories of the shift registers, or the registers we can call it. Okay. So these four categories of the shift registers are going to be combined together to form the universal shift registers. So here is universal shift registers. So its meaning is, so there are four different types of shift registers. So all these four types of shift registers can be constituted or can be combined together to form a single shift register that will be doing the purpose of all these four shift registers. So that's why it is called the universal shift register. So universal shift registers will be constituting all the four categories of shift registers, that is SISO, SIPO, PISO, and PIPO. So the structure of the universal shift registers is given here. So this is the universal shift register. So in that, again, it is a 4-bit universal shift register, you can call it. So it is a 4-bit universal shift register. So if there is a 4-bit universal shift register, then this is 4 flip-flops will be used. So here the flip-flop 1, flip-flop 2, flip-flop 3, flip-flop 4, or you can just name it different way, because based on the values, so A0, A1, A2, and A3 values are given. So we can name it like this is 0, this is 1, this is 2, and this is 3. This is how the numbering of the flip-flops we will be doing based on the output that is given. The Q is there. So Q is being named here as A0, A1, A2, A3, and likewise. So one by one, we will be looking it out, like how it has been categorized into 4 different types of shift registers into a single case. So for designing the universal shift registers, so here 4 flip-flops are used because 4-bit universal shift register it is. And after that, because in case of different shift registers, serial in, serial out, so this shift register, universal shift register, should be constituting the different criteria, like it should be able to provide serial input. Similarly, it should be able to provide serial output, and then also it should be able to provide parallel input, and it should be able to provide parallel output. So these 4 categories needs to be implemented by this circuit. So one by one we will be looking like how it is basically going to work as shift registers, like serial in, serial out, serial in, parallel out, likewise, or the shift registers that it is shifting, basically how it is basically shifting, we will be looking it out. So you can just see here. So these are the flip-flops. So 4 different flip-flops are there, and the Q, that is the output of the flip-flops, and D is the input to the flip-flops. So once we go with, suppose, serial in, serial out, so in that serial in, serial out, in the sense we should be providing the inputs from this D. D is like the 3rd flip-flop is there. So input, we will be providing the input serially, means 1 bit at a time. So 4-bit input is there, suppose 1, 0, 0, 1 is there. So we'll be providing this 1 to here, then this 1 that we have provided in 1 clock cycle here. So same 1 will be transferred to here in the flip-flop 2, then from next clock, for the next clock, this one will be transferring to next one, that is flip flop 1, and then from flip flop 1 to flip flop 0, and then it will be outputted. So that is how the serial input will be there. So in that case, to constitute the serial in, similarly, we will be inputting parallelly also. So to constitute the serial in, serial out and parallel out, there is the combination of mux that is being used. So 4 flip-flops are there. So each flip-flop has been assigned with one 4x1 mux. So 4x1 mux we already know. So in 4x1 mux, its meaning is 4 inputs will be there and 1 output will be there. 4 input and 1 output. And these 4 inputs will be transferred to 1 output one by one based on the select line. So 2 select line will be there. So if 4 input is there, so 2 to the power 2, that is 4. So 2 will be indicating the select line. So 2 select lines will be there, S0 and S1. So based on the select lines, out of the available 4 inputs, which input should be given as output of the mux is decided. So mux will be deciding, like, the output of the mux is connected to with the D, that is the input of the flip-flops. So in all the cases, the output of the mux is connected with the input of the flip-flop. That meaning is, whatever is the output of the mux will be there, that will be considered as the input to the flip-flop. So input to the flip-flop in all the 4 possible cases should be given either in it will be serially in, then it will be parallel in or serial in. Likewise, it should be given. Okay, so based on that, or if it is serial in and serial out is there, so the output that is available of the first flip-flop should be given to the input of the second flip-flop. So that is basically constituted by the mux only. So mux is here playing an important role to basically distribute different inputs to the input of the flip-flop. So in different categories of the shift registers, there is a requirement to have different inputs. Okay, so that is basically constituted by the mux. So one by one we will be looking here. So here the select line is going to play the important role. So the universal shift register should be working in what particular mode, it is decided by the select lines. So what different modes will be there, that is given into this table. So here select lines 0 and 1 are basically considered as the mode control pins, you can call it. So these are the mode control pins. So when the S0 and S1 is 0, 0, at that time there is no change. No change in the sense there will be no operation, you can call it like. So suppose S0 and S1 is 0, 0. So S1 and S0 are 0, 0 in the sense whatever is the input at 0 pin or 0, this 0 as the input, so this is the input 0, that will be placed at the output Y, and now this Y will be given to this D. Okay, so similarly you can look at it here. So what is this 0 basically? So this 0, from where it is coming out? So it is coming out to be from A3. A3 is there, it is connected with I0. This is like I0, I1, I2, I3 of the mux. Similarly, A2 is connected with the I0 of second mux. Similarly, A1 is connected with the I0 of the first mux. Okay, so then 0th mux, likewise. So likewise, this is connection is being given. So when the S0 and S1 is 0, 0, at that time there will be no operation or no change. No change in the sense, initially suppose the flip-flops are having 0, 0, 0, 0 in the sense A0, A1, A2, A3 value is 0, 0, 0. If it is 0, 0, 0, the same 0 will be when select lines are 0, 0, and at the same time, suppose select lines S0 and S1 is 0, 0. At that time, whatever is the A0, that is 0, 0 will be given to again D flip flop. So again, the output will be 0 only. Because in D flip flop, if we are providing 0, the output will be 0. You can note it down like here. If this is the Qn, that is present state, and this is Qn plus 1 into D flip flop. In that case, if present state is 0, next state will also be 0. If present state is 1, next state is 1. This is the case. So similarly here, if select lines are 0, 0, at that time, A0, A1, A2, A3 is 0, 0, 0, 0. So if this is the case, it will be retaining the value same. Same value is being feedback. It is given again to D. So it will be having the same value. So it will be retaining the same value. So that's why there will be no change. So either A0, A1, A2, A3 are 0, 0, or it is 1, 1, 1, 1 also. Then also the value, next state value will be the same. The next state or next state will be having the same value. There will be no change. If S0 and S1 is 0, 0. So this is the first mode of operation. The next mode we will be considering is here when select line is 0 and select line S0 is 0 and S1 is S0 is 1 and S1 is 0. That means here the S0 is 0 and S1 is 1. So when this is the case, at that time, how the connection will be looking like. So if this is the case, how it will be connected, or the circuit diagram you can redraw also, or we can just say here is like in the first case, this is the circuit diagram. You can just draw like what we have already seen in the previous class, like how the relation between shift registers are there. So if this is the shift register, this is like the D3, D2, D1, D0. So if S0 is 0, S1 is 0, at that time, whatever its output is connected with itself. So there are clocks. So this clock, all clocks are connected with the same one. Okay. And whatever is the input of D3, input of the D3 is connected with the A3 itself. It is connected with the A3. Similarly, output of D2 is connected with D2 itself. This is connected with D1 itself. Like this. So if this is the case, then there is no change in the value. This is the case when S0, S1 is equals to 0, 0. Similarly, if we talk about the next case where S1 and S0 is equals to 0, 1, is the case of 0, 1. If 0, 1 is there, so we just need to check like from where the D is connected, D of the flip-flops. So D of the flip-flops are connected with which value. Okay, so we will be looking it out. So you can just say if S0 and S1 is 0, 1, it's meaning in the mux, it will be selecting the input this one. So like this is the input that will be selected as the output Y, and this Y will be applied to the T. So in this simplified view of the shift register, if S0 and S1 is 0 and 1, at that time this 1 will be selected. So this 1 will be selected, and this 1 is connected with serial input for right shift. So right shift in a sense, suppose here the value is 0, 0, 1, 0. If this is the value, this is the serial input. So here this is the serial input in the sense we are providing the input from here. Okay, so we are providing the input means it will be selecting one bit at one time. For the next clock, next bit will be selected. For the next clock, next bit will be selected through the I1 pin of the input of the mux. Okay, and it will be considered to the input of the D flip flop. So you can just see here. So here the serial input, we are starting with the serial input here. So serial input, its meaning is if S0 and S1 is 0, 1, or S0 and S1 is S1, S0 is 1 and S1 is 0, at that time, if this is the condition, at that time the serial input is directly connected with the D input. So D3, it's directly connected to here. Now at that time, you can consider this one. So this is the second. Similarly, if select line is there, this select line is common for all the 4 muxes. So if for this mux also, this I1 will be connected to the Y and this Y is connected to D. Means the input of the D here, D2 flip flop, is connected with which one? It is connected with, you can just see here, it is connected with this output of the D3. So output of D3 is connected with D2. Similarly, the output of D2, this one is coming here and it is connected with this one. Because select line is common, so this one pin will be connected with Y and it's given to the D. That's meaning the output of D2 is connected with D1. Similarly, the output of D1 is connected with here. And finally, we are getting the output that is A0. We are getting the output here A0. And this is A1, this is A2, and this is A3. So this is the A0. So we are getting the output here from here. So you can just look at it like here. So we are getting an output from here. So this is the output. You can consider it here as a just serial output. Serial output for right shift, because this is the right direction. So shifting in this direction is basically the right shift. So here serial output for this is right shift. So that will be the point A0. A0 will be the serial output for the right shift. Okay, so from here we will be getting the output. So it is going to constitute, first of all, it is going to have the shifting in right direction, but it is basically constituting the serial in, serial out condition. So the first one can be implemented by using the case where S0 is 1 and S1 is 0. So this is going to work as a serial in, serial out. At that time, it is right shift. Similarly, the same thing can be done serial in, serial out, but for left shift. So left shift in the sense, if similarly, if the S1 is 1 and S0 is 0, at that time the same functionalities will be there, but it will be now shifting the left side. So you can just modify it. Okay, so you can just see here like how it is basically constituting the left shift. So if it is left shift, S1 will be 0, S0 will be 0. So this is basically for the left shift. So how it is shifting in the left direction? So you can just see here. So if select line is, if the select line is this S1 is 1 and S0 is 0, in the sense it will be selecting the second input. Second input it will be selected. Okay, so you can just look at it like where the second input is connected. So second input is connected with the output of this one. So this configuration we will be changing it here. We will be looking like how it is constituting the left shift basically. So left shift in the sense we are providing the input from here. So input is being provided here. So if it is 0, 1, 0, 1 is there, is the input here. So it is shifting in the left side. So this is shifting in left side. Shifting in left side. So shifting in the left side in the sense we are putting the data from this side, left side, and it's moving to putting the data from the right side and it is going to the left side. So how the inputs are provided, you can just see here. So this 2 will be selected as output of the mux, and it will be connected with the D. So this 2 is connected to what? So just look at it. This is connected with the A2. So the input of this one, D3, D3 mux, D3 flip flop will be given by the A2. So A2 is this one. This one is the A2. A2 is connected with the D3. Similarly, this is the case. This is the case where for the second flip flop, the input, because based on the select line, 2 will be selected as output of the mux, and this will be connected to the D. But this 2 is connected to what? It is connected with A1. So it is connecting with A1. So D is connected with A1. A1 is this one. Okay, it's connected with A1. Similarly, in case of here, so if we talk about the 2 here, so flip flop D1, its input is connected to this 2. So this 2 is basically connected with the A0. The A0 is this one. The A0 is connected with the input of D1. Similarly, you can just look at it here. This is the 2. This 2 is basically the input for the D0. This D0, the input is 2. And this 2 is basically connected to what? It is connected to serial input. So this is the serial input. Serial input for left shift basically. So means from here we will be providing the input. Then from this location it will be shifting to here. From here to here, here to here. Likewise, so if you put 0, so for one clock the 0 will be here. In the next clock the 0 will be here, and here becomes 1. This 1 will be coming here now. In the next clock, this 0 will be coming. This 0 will be coming here. This 1 will be coming here, from here to here, and this 0 will be coming here. Similarly, in the next class, this 0 will be coming here. This 1 will be coming here, and this 0 will be coming here, and here again 1 will be there. So it's shifting. So initially it was 0 1 0 1. So in case of the flip flop we talk about, so it is 0. All will be 0 initially. Initially all flip flops will be 0. Then this 0 will be coming here. Okay, and here all zeros will be there. Then this 0 will be coming here, and there will be a 1 here. Similarly, this 0 will be coming here, this 1 will be coming here, and another 0 will be coming here. Then this 1 will be coming here, this 0 will be here, this 1 will be here, this 0 will be here. In the next clock, this will be the output. So serial output will be taken from where? It will be taken from A3. So A3 will be the one that will be the having the serial output. So this will be the serial output for left shift. So I hope you are getting this. Okay, second we have seen. The third we will be looking like how it is basically constituting the parallel load. So parallel condition we will be looking how it is considering the parallel load condition. So in the parallel load conditions, basically when select lines are 1 1. So when select lines are 1 1, then the input, that is I3. I3 will be selected as input to the D. So we will just remove this and we will be considering again. So what is it basically? Okay, so based on the configuration of select line, so here this 3 will be taken as input to D3 basically. So here the input is, you can just look at it. So this 3 is connected to I3. So this is I3 in the sense we are providing I3 here. Similarly, in this case, in the second flip flop, the input D will be connected with the I2 because the select line are 1 1. So 3 will be as connected as output. So this output will be input to the D2. So I2 is connected here. Similarly, I1 is connected here, and similarly I0 is connected here. D. Okay. Next, if this is the case, now you can just look at it. If this is the case, so in that case, we are providing this as the inputs. So parallel input is there. So one thing, so 4 possible combinations are like this here. So serial input, serial output, serial input and parallel output. How to implement the serial input and parallel output? How we can do that? So once we were serially inputting, at that time all the output pins are connected here. So if we want to take the output, you can take the output at one time only. So at one time we can take all A0, A1, A2. So parallel output we can do. The serial input for the right shift will be from here, and we take the parallel output from here. Similarly, if it is left shift, we will be taking the parallel output from here only, but the input will be given from here. But in case of parallel input, so two conditions are there for parallel input. So for parallel input, this is the condition. If select lines are 1, 1, the parallel input will be there. And the next two cases are either serial output we are taking or parallel output we are taking. If we are taking the parallel output, we will directly taking the output from A0, A1, A2, and A3. We can take the parallel output directly. If we want to take the serial output, so if we want to take the serial output, in that case, you can just look at it. If we are putting the input here, parallel input we have put. So after putting the parallel input, if we want to take the serial output, in that case, we have to basically think of like we have to run it either in left shift or right shift. So once we will be inputting the data in parallel, so it is like 1, 1, select lines are 1, 1, then it will be parallelly taking the input. So after taking parallel input means all the inputs, suppose the input is 1, 0, 1, 1, 1. So if this is the input, so in one clock cycle, all these inputs will be available into the flip-flops. So it will be 1, 0, 1, 1. But we want this output in serial case. So if we want the output in serial, so either we can take like serial left side or right side. So we can select either like 0, 1 or 1, 0 select lines. So we will be getting the output in either left side or right side. Means we will, if suppose we have taken the select line as 0 and 1. So if we have taken 0 and 1, then we will be getting the output from here because it is right shift. So output we will be getting from A0. So in the next clock, we will be getting the, in the first clock itself, we will be getting the 1 here. In the next clock, it will be shifting it here. So after shifting, this 1 will be coming here, this 0 will be coming here, this 1 will be coming here. So we will be getting again a 1. In the next clock, we will be getting this 0. In the next clock, we will be getting this 1. So in one clock of the case where S1 and S0 are 1, 1, we will be getting the input to the flip-flops. At the same time, we will be getting the output also. First output will be big. In the next 3 clocks, we will be getting the next 3 inputs as output in serial case. So this is how universal shift register basically works for different possible cases of the shift registers. So it can constitute all 4 combinations of the shift registers. So that's why it is called like the universal shift registers.